Very good morning to all. Today let us discuss unit number 5, which is signal conditioning and data acquisition system. Till unit number 4 we have seen so many sensors. Okay, so sensors may give analog or digital outputs. This analog or digital output cannot be directly taken into system for your next step of processing, because they need some conditioning system. Conditioning means that the signal from the sensor should be of particular value, but it may have some noise in it. Okay, so this noise will also travel, and you have to separate this noise. Then the signal, before entering into the rest of the circuit, you have to do some amplification. So this removal of noise and amplification comes under signal conditioning. And data acquisition is nothing but how you are going to store this data, or with this data how you are able to generate the original pattern. See, for example, if you have a sine wave, the sine wave will be varying in nature, and your sensor will continuously sense and give the digital output. Say it may give analog output, then you go for signal conditioning, then you convert it into digital. Then this one set of digital value is not the entire signal representation. So the entire signal, if you want, you have to go for 100 or 200. That becomes the resolution of your signal. So all such things comes under data acquisition system. So this unit number 5 is as follows: like amplification, filtering, sample and hold circuit, then data acquisition. You have single channel and multi-channel data acquisition. Then comes data logging. Data logging is, see, if you say as a single sensor, then you get the information from the sensor and you take the corresponding action. But if it is n number of sensors, then it becomes like a table, then it becomes like a PLC programming. So once you call PLC programming, the first sensor value will be compared with second sensor value, then third sensor, then based upon the result you have to take the decision. Like that it becomes like a table, or what you say, lookup table, or it is like a ladder. Only if you climb first step, second step, you can go to the third step of the ladder. You cannot directly go to the fifth step. So which means the combination of first input output from the sensor will be then used for the corresponding work. So that is called as, I need a group of data, so that becomes data logging. Okay, so entire data will be logged. So one more example, better example if you want to know, is aircraft, then your air missile, then satellite launching. All this will continuously get information from the base station to the rocket. Similarly, from rocket you will get the information to the base station. Okay, that base station, when it receives it has to be stored and it has to be referred, so that you call it as data logging. So this here chapter unit itself, I can split it into two. One is data acquisition system, then data logging system. Okay, so again in data logging they have given some application like automobile, aerospace, home appliances, manufacturing, environmental monitoring. Okay, in a manufacturing industry, how we are going to monitor what is being done. Okay, so let us start with first part of the unit, which is called data acquisition system. Data acquisition is the process of sampling the signal. Sampling the signal is, see, for example, when you say input sine waveform, which is nothing but your EB sine waveform, and if I want to trigger at a particular instant, say alpha is equal to 45, I think you might have studied rectifier, controlled rectifier and all. So you must know what is called firing angle alpha. So okay, if you have a alpha of 45 degree, which means after sine starts, I have to wait till sine reaches the angle of 45, then I have to start triggering the circuit. So all this requires sampling of the signal. So how you are going to sample, whether by entire sine, one positive off cycle plus one negative off cycle, the total time is 20 milliseconds. I think you know, because it is 50 Hz. So 1 by 50 is nothing but 20 milliseconds. So this 20 milliseconds, how you are going to take the data? So I can divide this 20 divided by, I can do 20 or I can do 20 divided by 50, 20 divided by 100, or 20 divided by 200, and if a denominator term is go on increasing, the number of resolution will increase, or the pattern which I am reproducing the signal will be more accurate. So that is called, we call it as sampling the signal that measure the real world physical condition and converting the result sample into digital numeric value that can be manipulated by the computer. So once when you use computer for manipulation, so manipulation can be done only after getting the numeric value. So this numeric value can be obtained by the value of called sampling. Okay, data acquisition system abbreviated by the initials like DAS, DK, DAQ, DAU typically converts analog waveform into digital values for processing. Okay, the data acquisition system consists of a sense of physical variable that you call it a transducer. That is what we have studied from the day 1 of this sensor and transducer. So we have studied so many transducer. So first of all, they play the role. So they is for sensing the physical variable. So once this variable has been sensed, the output will be electrical signal. So signal conditioning for the electrical signal. So any output from the sensor cannot be directly taken for processing because it may contain noise. So you need some called signal conditioning of this electrical. It is readable by a to D board. So once after removal of the noise only you are supposed to go for analog to digital conversion. Otherwise you will not convert your analog, or you will not convert your input, rather you will convert your noise. So third step is convert the signal into digital format acceptable by computer. Okay, so first what they do is first they go for transducer. After transducer, second step is signal conditioning, and third step is conversion of analog to digital. Then process, analyze and store. All this is the role of the computer. Process is nothing but how you are going to predict what the step you have to follow, what is the next step you have to follow. Analysis, you have to compare with the reference. If you have any reference, we will compare it with the reference. Then store for further reference in future if you want, then we will store. And display the adequate data with the help of software. And when you want to go for human machine interface, we call it as HMI. So that in that case you will have a display units. So this is the block diagram of data acquisition system. So it starts from physical system. Physical system is nothing but you have installed some type of system where the system has to be monitored. So monitoring the system, for example an air conditioned room, and if you want to monitor, you will have a transducer to measure the temperature. So once this you measure the temperature, it will be like this in fashion, and all this is our noise. When you give it to signal conditioning, that will try to remove this noise, and this signal is little bit weak, so I will amplify it. So once if I amplify it, so this is an amplified filtered output that we call signal conditioning. All type of condition on the signal. So what and all condition is done, noise is been removed, signal level has been amplified. Then I will give it to A to D converter. Here comes your resolution. Higher the number of sampling, the more the amount of resolution. So once you do for each and every step, you will have each and every step as an digital output. So this entire digital output will represent this signal. Okay, so the sine wave cannot be represented by a single analog. So we will have a various analog digital values. This entire digital value will represent this sign. So now we have only obtained the data. So now only we have obtained the data. Don't think that by a transducer itself I will get the data. Transducer is nothing but only a sensing device. He will sense and give the signal, and the signal once received from transducer will have noise as well as weaker in amplitude. So both you have to remove the noise as well as you have to amplify. That is being done with the signal conditioning system. Okay, so convert physical phenomena into measurable electrical signal. That is what the first fellow transducer. So if you have we have shown here light, don't assume it is light of the bulb and all. Some light source, give it to transducer, you will get an electrical output. So the intensity or the brightness of this light is converted by the transducer as an analog voltage. This analog voltage is the data of this particular intensity of this light source. So when you take transducer, there are different types like temperature to electrical, light to electrical, sound to electrical, force and pressure to electrical, position or displacement into electrical, fluid flow into electrical, and pH. pH is nothing but we say the pH of the water. Okay, so acid base content of the water, so into electrical signal. Then in signal, what is there inside signal conditioning is you have amplification, filter and isolation. What is the term isolation is anything from my secondary side should not travel to primary side. It should be one way direction. One way means from sensing to my computer side. From there I should not have any travel on backward. So you should always have an isolation. Okay, so amplification, when you talk, when the input signal is as small as microvolts, electrical noise can drown out the signal itself, leading to meaningless data. So when you take a signal from a brain, for example when you take ECG, or when even some advanced technology you try to take the signal from the brain, where the signal and all will be very very weak, or even you cannot capture it. If you try to capture, only you will capture the noise, but that signal is from the brain, is controlling your hand movement, your voice or everything. Okay, so there comes the need for amplification. For the reduction of the effect of noise on your signal, it is to amplify the signal as close to the source as possible. Then increase the signal to noise ratio, which means signal level should be high, noise level should be low. That is called SNR, signal to noise ratio. Example, a J-type thermocouple output a very low level voltage signal that varies for about 50 microvolt per degree. Say assume if there is change in 1 degree, only 50 microvolt, not even millivolt, it is microvolt. So it is a very low value. So you have to do amplification so that it can be brought to the level where it does not get lost, the data is not lost. Filtering, there are so many types of filter. You might have studied some analog filters, but there are some digital filters. So to reject the unwanted noise within a certain frequency range, many system will exhibit 50 Hz periodic noise from a source such as power supplies and machineries. See, if I am already having some analog output and if I am mixing it with my EB, so this 50 Hz will automatically come into your signal. This 50 should be avoided because it is a noise. So there are, you might have studied a subject called digital signal processing. Okay, where you might have studied this Butterworth, Bissell, then Schiber's filters, then simple RC filter, passive and active filters. This passive and active filters are different from these digital filters. So digital filters plays a major role, like you can select a particular window and that particular window frequency alone you can allow, and the remaining frequency you can cut it. All that such things is not as easy in your simple RC and passive active filters. Okay, so that is the difference between a digital and a normal filter. Then comes your isolation. Isolation plays a major role. You should avoid all grounding issues and you have to avoid all circulating issues. So circulating current or grounding issues, we will see how we have to avoid this. So improve grounding of DAQ system is the most common cause for measurement problems. There are no physical wiring between the input and the output. the input is normally transferred by converting into optical or magnetic signal. So what we do sorry what we do is we does not allow the signal to travel in the electrical medium itself, because there is a chance for noise to get added, because in the environment you have more noise. I think you know why we say. You might have connected a probe to a CRO. Without connecting to any equipment itself, you will see a sine wave. It will not be a pure sine wave, a distorted sine wave. You may or may not, you might have not thought, or you might have thought that to be a signal. That is not signal, that is the noise. So what is this noise? Which is nothing but your microphone or your mobile phone radiations. See, we are sitting inside a room with full of microwave, that is from your signal for your mobile phone. IEEE standard says it should not be not more than 50 milliwatts, but a developing country like India, where we expect the signal to be present all over, wherever you go and sit, you should get a signal there. So our people, what they do is they go for 1500 millivolt, which is nothing but 1.5 watt. So 1.5 watt of power is being transferred into your body 24/7. That is why we say try to avoid usage of cell, try to keep it away. So at least with this 1.5 watts you can escape. If you always keep your mobile very close, then you will receive more than this 1.5 watts of power, so which causes a damage. So when we cannot say avoid technology, we cannot say throw away the mobiles and all. They are very important. With respect to safety issues, we should have a mobile so that you can communicate. All that thing is acceptable, but don't keep like a child always with you. So try to avoid, try to use when you need. Okay, so that is reason for this noise, and this noise will try to get from your wires. So that is why what we do, we will convert the electrical signal always to light or magnetic field. So this electrical noise will not come into picture. And again at receiving station, again we will convert it into light into electrical in order. So this we call it as isolation. Okay, so grounding issues. See, you can see here, this is properly grounded and this is called floating ground. See, your signal ground and your ground is different. So what happens is, this is a different ground, this is a different ground, so it becomes floating. So floating will always have some issues like circulating issues. So there will be some circulating path and all, that will create noise. A signal is referred to a system ground, earth ground or building ground. Example, power supply, signal generator, anything that pulse into output, you call it as ground signal. Okay, then floating signal is not referred to a system ground. So you may have your AC supply as well as you may have some batteries. So this battery ground will not be same as a supply ground, so that we call it as floating ground. And when you use some type of sensors, you need some floating ground also, but try to see through that floating ground will not pick up the noise. Okay, so this is what we say as ground loop. There are two different grounds, and when you connect a positive and negative terminal, there is an inter circulation, that is also a noise. So these two noise you have to eliminate. This only we will call it as common noise and differential potential. Common noise and differential potential. So this, how to avoid this circulation is, go for twisted wire cable. Don't use separate wire cables, go for twisted wire. So when you go for twisted, this end will become this end and this end will become this end, and you are, since it is twisted, this will get entirely zero. And this ground problem can be solved by totally you have to isolate. So that is what we do with isolation grounds. So for isolation, you have two types of isolation. One is called optical. So when you give electrical signal, then it will be converted into light source and light will be sent. Okay, another one is magnetic isolation, where you go for transformers. So you give it to primary side and you take from secondary side. So you don't have any primary secondary direct contact, but this is 1:1 ratio is there. So what you connect on this will be a same. So without any increase or decrease, there is not step up or step down. It is what you give it on primary will be on secondary with same turn ratio, but only thing is you provide isolation. So I think you all know in your transformer you have a isolation between a primary and secondary. Then eliminating the ground loops, you have to go for what I have told, all that thing you have to go. The signal isolator breaks the galvanic path between the two grounds. Okay, so you have to do proper procedure like putting in isolators. So once if you put isolator, they break the path of the galvanic path. So once the galvanic path is broken, since it is only light is going to be traveled, so that is how we will try to eliminate it. So signal conditioning are sometimes referred to as signal transmitters, ground loop isolators, which means removal of ground loop, 20 to 40 milliamps transmitter converters, isolators, then analog signal converters, analog signal isolators. So all these are the device with doing the same work of signal conditioning only. Okay, they are called by these names, but they are all called as signal conditioners. Now let us move on to data acquisition, where in data acquisition your signal is there. Okay, then comes your terminal block. For example, you capture the signal at your college level and I want the signal to be used in IIT. So first initially it will go to terminal block, where this will be placed in your college. So this signal will be converted and given as an input here, terminal block. So it is like internet. If you have modem, you call, no, similarly this one is. Then it will be traveled through cable. Now here it will maybe electrical signal, where here it may be only in optical fiber. We will try to transmit using a device. Then this DAQ converting of this, what you are getting here into analog value, you will have DAQ devices, and that will be connected in the system which is there in IIT. So signal from here is being used to transmit and received. Why you want to have this is because I will have my source station at so many places and the processing at a destination will be at a particular place. If you want a clear idea, I will tell example is wind stations. There are so many wind stations in Tamil Nadu, but all the wind station has to be controlled, which means the amount of wind on the wind blades. So what you will usually sense is, you will sense the wind speed. The sensed wind speed of various locations has to be brought to the center controlling station. We might have seen a government office opposite to our college. Previously it was called as SVINOD. Now it is called as National Institute of Wind, where they collect the information and they will try to record. So this is how we have data will be got there from the terminal block. It will be converted into some other form, will be transferred for the long distance and received by the system at the far end. Okay, very latest technologies, your all Google servers will all work like this. Okay, then terminal blocks and cable. So this terminal block which is going to convert, it is a 50 output, is like a 50 pin connectors. You can get it in analog value, you can get it in a digital value, you can whatever way you want, you can convert it and send it to the cable. So terminal block and the cable route of your signal to specified pin on an DAQ system. Then things to be considered is connection to the internet is their software support. So if you want to send any data, you will send through internet. The type of input channel like single-ended channel or differential input channel is there. Then compatible with the variety of bus protocol. I think you are in third year. When you come to next year, you have a paper called embedded system. In that embedded system paper, we will try to explain you. That is today, this semester only you have started with a subject called microprocessor. When you come to embedded system, you will understand in little bit in depth. We will see what is called as this bus protocol and all. Bus protocol, you have so many protocols like CAN protocol, I2C protocol, SIP protocol and all. Protocol is nothing but a way by which data is being transferred, that's all. The method by which you are going to transfer. The number of analog input channel, sampling rate I have told you already. Sample rate is nothing but if you have a signal, how much part you are going to divide, whether divided by 100, divided by 1000, divided by 2000, that we call sample rate. Higher the sample rate, you will have higher the resolution. Higher the resolution, you will have higher the accuracy. Then reduced broad size. Then plug in data acquisition card. Okay, when you plug in data acquisition card, it will have all inbuilt conversions, so automatically it will convert. So for example, I have told some protocols, so all these protocols will be inbuilt here. So when you give the data, automatically it converts into that particular protocol and try to send. Okay, the function of TIQ is analog input to digital output, digital input to analog output, convert counters and timer functions. You might have come across something called counters and timers. So in detail we will see what is counters and timers when you come to embedded system. A counter is going to count from a value you have loaded till the value you have also loaded to reach. Timer, both are same, only difference between counter and timer is for everything you need clock. Both counter and timer requires clock. If the clock is from external, then it is counter. If it is your own clock, then you call it as timer. Okay, so timer will run on inbuilt clock and counter will run on external clock. Only that is the difference. So analog inputs, when selecting A to D hardwares, the number of input channel, single-ended, resolution and input range and the gain, all this you have to specify, because if one analog to digital is working on one resolution and the far end if it is with different resolution, then the entire data is collapsed. So both should be of same resolution, both should be of same sampling rate, then only you will get the same output. Then comes your gain. Gain is nothing but the term which you multiply or the term which you amplify. Okay, A to D converters, so each and every instant of your wave is converted into a single analog value, and when you combine all that, again you will get back the original data. Higher the sampling rate, better the signal we get. Accurate signal gets distorted if the sampling rate is too small. This is what I told you. So let us assume this is sine waveform. If you are taking at 4 point number 1, point number 2, point number 3, point number 4 and point number 5, only 5 data I am taking. We assume sampling rate is 5. If sample rate is 5, what will happen is, on my receiving end, after receiving, if I convert, my sine wave will become a triangular waveform, because it started here, it has a maximum, it has a minimum, again it has maximum, it has minimum, it will become triangle. So entire data itself lost. Input sine was now triangle for you. So when you want as a sine itself, you should have more number of steps. This more number of steps is nothing but more number of data. Even this is a resolution is less, you can go further for higher resolution, that is like more sample rate or more part you have to divide this, then only you will represent your sine waveform. Nyquist sampling theory, so that is a theory which is used for sampling your sine. Tells us that we must sample the signal at more than twice the rate of maximum frequency. This is what they say. So if your signal is 25 kilohertz, you have to go for 50 hertz sampling, 50 kilohertz. Okay, so that is what that Nyquist says. According to Nyquist theory, the sampling rate must be at least 2 max, where the highest frequency component is f max, so you have to go for 2 max. So that is what Nyquist says. Range, the maximum and minimum voltage that ADC can digitalize. So when you take all ADC, they will give what is the maximum range and minimum range. Range are selectable, so you have to select so that you have to get more range. Resolution is number of bit in the ADC uses represent a signal. change can be measured. 12-bit resolution means 12 resolution is nothing but 2 to the power 12, which is nothing but 4096 levels. So 4090 levels in your conversion. So larger resolution, more precise the representation is. Then comes gain multiplication. So gain settings like multiply by 0.5, multiply by 1, 2, 5, 10, 20, 50, 100 for most of the device. Proper gain, we should not go for more or we should not go for less. Correct percentage of multiplication will give you a good result. Then analog outputs, see somewhere you require digital outputs, similarly you require analog outputs also. So digital to analog devices allow the computer to control real world events, because no real world will work on digital, all real world will work on only analog. Only your computers will work digital. So your input for your computer you require digital, whereas from the computer there are a device which will work only on analog real world. So analog output signal may be directly control the process equipment. Process can give feedback in the form of analog input signal. They are referred to closed loop system with the PID and so on. This counters, I have already told, counter bar timer is a device, provides a variety of measurement solution, including measuring the number of time related quantity. If you want to get an example for counter, number of car in a parking slot. Okay, a timer is, I have a washing machine, I am washing the clothes, so I will have a motor. Ask the motor to rotate in clockwise direction for 15 minutes, then stop. Ask the motor to rotate for reverse direction 15 minutes. Now how you are going to calculate this 15 minutes? Then it is a internal clock. Here I will not wait from external, one round is over, two round, it is only with respect to time basis, so we call it as timer. So that is the difference between a counter and a timer. Both they get the clock, but this fellow will get the clock from out. This clock is internal clock. So for a counter, when a car enter in a parking slot, it gets like a clock. Okay, one clock, one car has entered. But whereas in timer, it is a continuous pulse from your internal clock itself. So that is the difference between these two. The frequency measurement, edge or event counting, pulse width measurement, event timestamp, pulse width modulation are the various use of timer bar counter. Again we can see there are so many software packages for data acquisition. We know there are like C++, then Visual C, Basics, Visual Basic Plus, and there are so many add-on tools which are available. In data acquisition, software package does not require programming, which has already been programmed. For example, when you buy a modem nowadays, it comes with the software, it is preloaded. So there are some softwares which can use for testing of the modem, all that thing like test point, snapmaster, labview, dspic, dslab, etc. Okay, so example for entire data acquisition system, you can see here you have a sensor here. So from that sensor I will get the instrument amplifier. So once that sensor gives the output, that has been amplified. I think you should know why I have put a box here, because it is a Wheatstone bridge. You might have seen so many transducer with the Wheatstone bridge. I think this will be a variable resistor. So depending upon that you will get the signal. So that is being given to an amplifier. So once it is being given to amplifier, you give filter. Then it comes to S bar H, which is nothing but sample order volt. Sample order volt is for what is the time duration for which I have to take the next input. See, when you giving the data for every 0.5 seconds or every 1 second or every 1 minute, I will allow the data to ADC. I cannot continuously allow to the ADC, because ADC also takes some time to conversion of analog to digital. So this fellow will try to make, if you specify sample hold to be 2 minutes, so for every 2 minutes it gets the information and pass it on this side. Okay, then you all know with analog to digital, you will convert. Digital itself is parallel, give it to input. There are something where you get digital to analog, then you have some application like timer, triggerer. So timer, I told, no, if you keep 1 minute, after 1 minute it will trigger here, that 1 minute will come and trigger here, this trigger will make the signal to enter. So this timer will control that sample order hold of your system. So this is what with respect to data acquisition system. Thank you students for listening. So if you have any